Okay, so the next one, I want to do a couple of more example, guys, so that we can see how ratio proportional conversions will work anytime, as long as you're, of course, using the right conversion factors. So I'm here, example 9.13. Example 9.13. And this problem we're going to solve several ways. So what they want you to figure it out, calculate the mass in grams, of which are the following. So I'm going to do just one of them. So they give you the single molecule of CO2. Single molecule of CO2, okay? And what they want you to do is they want you to figure it out mass in grams. In grams. So the easiest way will be, of course, is that we know that CO2, the mass of one molecule is 44.01 AMU. Mass of one single molecule of CO2. Now, remember the conversion factors, guys, I did right before. The 1 AMU is equal to 1/12 of the mass of carbon-12 isotope atom. And so the conversion factor was 1 AMU was equal to 1.661 10 to the negative 24 grams. And so this is nothing else, guys, becomes a conversion. 1 AMU is 1.661 10 to the negative 24 grams. This and this canceled out, and all I have to do is just multiply 44.01 AMU times this conversion factor here and get my mass of the in grams of one molecule of CO2. So let me do it. Times 1.661 negative 24. So this is what I got. Now 4 significant figures, 7.31, little zero here, 10 to the negative 23 grams of CO2. So in other words, 44.0 grams, the mass of one molecule of CO2 in terms of AMU. But what is the gram in grams? What is the mass in grams? This will be the equivalent mass in grams, guys. What's another way of dealing with this problem? Well, you can also do it this way. You can say that you're given one molecule of CO2, right? Of CO2 times. Well, what I can get now is that I can say that I can get into the moles. 1 mole of CO2 contains Avogadro's number, molecules, in other words, of CO2, molecules of CO2. I'm rushing a little bit, should really slow down probably. Okay, and so what I'm going to do next is molecules cancel out. So now I got the moles of CO2. If I got the moles of CO2, I can use now the molar mass of CO2, 1 mole of CO2, and from the previous videos, guys, you know how to find the molar mass of CO2. You look at the periodic table, you take this is 12.01 grams plus 32.00 grams, you add them up, and so you wind up with 44.01 grams of CO2, canceled, and pretty much you should, guys, get the same answer here as here. So let's check. That would be now 44.01 divided by 6.022 exponents positive 23, and so I got here how many sig figs? Well, 4 significant figures, 7.308 10 to the negative 23 grams of CO2. Now, there's a little discrepancy here between this and this number, and only because we rounded off number in here, it should be really 1.6605, and I can get more significant figures here, so shouldn't be worried about this discrepancy. It's just, again, the reason is because I rounded off this number, which was kind of intermediate number, and but still, if you're using 2 significant figures, you can see that you got the match in here. This is the same masses, and so either way will be correct in here. Now, I also want to solve, guys, one more problem. One more problem here. And this problem now will be pretty much combining all of the concepts we learned today. And that's where I'm going to stop my lecture. And until next time we see each other, hopefully face to face, because I know this is not an easy task for me now to present all of this, because I really don't know your feedback on this. You may be understanding it, you may not be understanding it. Again, contact me guys via email, and we'll definitely resolve any issues you got. But let me do one more example, 9.14. On page 356. All right, here's what's given. Caffeine, the stimulant in coffee, and it has the following formula. It has C8H10 and 4O2. And the question is how many grams of nitrogen present and 50 grams of sample of caffeine. Again, always guys put what's given first. So this is what's given. This is what's given here. Now, all right, let's see what they want from me here. How many grams of nitrogen in here? Again, I'm going to go all the way back here. I'm going to say grams of nitrogen in here. Okay. So again, this problem is nothing else conversion problem. It is a conversion problem. So what are the conversion factors here? Well, the first thing we know is pretty much that 1 mole of C8H10 and 4O2 contains, we're looking for nitrogen. 4 right here, that's what my 4 is coming from. 4 moles of nitrogen. And that will be a crucial conversion factor here, because you have to go from the entire compound, for the total thing, to something that's very specific, particular. Okay, so apparently grams have to be converted to moles, no doubt. And I know now that 1 mole of this substance, C8H10 and 4O2, will be equivalent, again, I'm going to do a real quick calculation of molar mass, contains 8 moles of carbon. I'm going to get in a moment 10 moles of hydrogen, 4 moles of nitrogen, 2 moles of oxygen, so that would be easy to do right away. So 4 moles of nitrogen will be a little more complicated. I have to do 4 times 14.01. I got here 56.04, and this one is pretty easy, will be 10.08. And then 8 moles of carbon, 12.01, will be 96.08. Again, I always go by precision here, and so I'm going to add all of them up. Plus 56.04 plus 32.00, and so I got here 194.20 grams. And the substance will be, of course, C8H10 and 4O2, my caffeine. Okay, so I'm ready to plug it right in here. 194.20 grams, C8H10 and 4O2. Cancel same units again. What's my next conversion factor? Well, very simple. Now we need to get the match. This matches this, so therefore I'm going to use it next. Will be 1 mole of C8H10 and 4O2, equivalent to 4 moles of N. All right, let me see, did I get my right units, mole grams? No. So I need to do one more conversion here. I'm going to say that 1 mole of nitrogen is 14.01 grams of nitrogen. Again, 1 mole of nitrogen, I got it from the periodic table. Just looked it up, it's 14.0 grams. 1 mole and mole cancel out, and pretty much that's the setup to solve this problem. So I'll do 50 divided by 194.2 multiplied by 4, and then times 14.01, and I get my final answer, 3 significant figures, will be 14.4 grams of nitrogen.